today we are discussing about the Hplc, that means high performance liquid chromatography. This is one of the chromatography. So it is a type of chromatography. So it is a biochemical specialist of in biological samples. So chromatography is a physical process whereby components, solutes of a sample's mixtures are spread by their differential distribution between the stationary phase and mobile phase. There are the two phases. One is the stationary phase and another one is the mobile phase. Planar and column are two basic forms of chromatography. High performance liquid chromatography is a form of column chromatography. During column chromatography process mobile phase and carries the samples through the column containing the stationary phase. As the mobile phase flows through the stationary phase, the solute may be. The residues only stationary phase, no migrations. Reside the only in the mobile phase, migrations with the mobile phase, distribution between the two phases, differential migrations. The basis of all forms of chromatography is partitions or distributions coefficient, that is coefficient. So KD is the coefficient that describes the way that the solute distributes itself between the two immiscible phases. Distribution of coefficient is constant at a given temperature of for two immiscible phases A and B concentration in phase 1 and coefficient is concentration phase B. The solute, how this is the solvent. So this is solvent reservoir. Then here is sample injection. So sample injection means Hplc tube. So ultimately it is detector. So finally signal is processing. So this is visual display. How the here is a pump. So it is 500 capacity. So column chromatography, the stationary phase may be a pure silica or polymer, or it may be coated onto or chemically bonded to support particles. The stationary phase may be coated into a tube, or it is coated on inner surface of the tube. When the mobile phase is liquid, it is called as liquid chromatography. When the stationary phase in liquid consists of some smaller diameter particles, the technique is higher performance of liquid chromatography. In analytical liquid chromatography, the mobile phase or eluent exits from the column and passes through a detector or a series detector that produces a series of electronic signals that are plotted as a function of time, distance, or volumes. The resulting graph is a chromatogram, that means gram, that means recording of these things. The retention of RTR, like this is the taken of each analytical peak emerge from the column. Under defined chromatography conditions of a column, this is the characteristics of the analyte. The value mobile phase required to elute the analyte under the defined chromatographic conditions is referred as retention and elution. Eluting the solutes are displayed graphically as a series of peaks. They are frequently referred to as chromatographic peaks. These peaks are described in the terms peak width and peak height and peak area. The data represented by the chromatogram are used to help identify the quantity of the solutes. Most important parameters in column chromatography is the partition ratio, so capacity ratio. Okay, the capacity ratio has units and it is measures of the additional time the analytical takes to elute from the column relative to unretained or excluded analyte that does not partition into the stationary phase. This is how the calculation. The capacity ratio characterized in the column the success of any chromatographic procedure measured by its ability to separate completely resolve on one analyte from a mixture of solute like a similar components. Peak resolutions is related the power properties of the peaks. So how this is chromatographic graphs regarding. So this is the things of about the calculations of manipulation. So peak asymmetric has many causes. Applications of too much analytic to the column, and poor packing of the column, and poor applications of the sample to the column or solutes and separate interactions. Chromatographic columns consist of a number of adjacent zones, such as each zone is called a theoretical plate and its length the column is called as plate height. The more efficient the column, greater the number of theoretical plates are involved. The plate number can be increasing the column length, but they are a limit to the, because the retention time and peak the time width increases the proportionally, length increases the, where peak height is decreases the square root of n. This is how peak is. Then good resolution determination the following three things: selectivity, efficiency, and capacity. Selectivity is measures of the inherent ability of the system, so discriminate between the structurally related components. Two structurally related compounds of Kd and K. The ratio proportions of coefficient two components gives relative relation tension. So efficiency of distributions effect that occur in the column to cause the peak broadening of overlap. So capacity is measures of the amount of material that can be resolved without causing peaks that overlap irrespective of actions like gradient illusions. So principles are like a Hplc. It is limit length of from a column is due to the problem of peak broadening. So the number of theoretical plates related from surface of area, stationary phase theory like therefore smaller than particular size of the stationary phase. The better is resolution. The smaller the particulars, the greater resistance to flow the mobile phase. The resistance in flow caused back like a pressure column in a column that in sufficient to damage matrix structure of the stationary phase. The smaller particular size stationary phase that can be withstand high pressures caused dramatic development in the column chromatography. So what are the instrumentations? The increased resolutions achieved in the Hplc compared to the classical chromatography in primarily result absorbance of the very small particle size less than 20 micrometers, large surface area. The smallest gel beds used in gel exclusions chromatography are superfine like grade with diameter 20 to 50 micrometers. The combinations of high pressure and the adsorbents of a smaller size leads to the high resolution power and short analysis of in Hplc. This is how diagram showing of pumping of these things, and this is the recording. So solvent reservoir. The solvent reservoir should have capacity at least 500 milliliters from the analytical applications, but larger reservoirs are required for preparative work. In order to avoid the bubbles in the columns detector, solvent must be degassed. Several methods are used from degas. So what are the things? So by warming the solvents, by vigorous stirring with magnetic stirrer, by ultrasonification, by subjecting the solvents to vacuum, or by bubbling helium gas through the solvent reservoirs. So what are different pumps? Theoretically, requirements for pump, it must be capable for pressures output at least 500 psi, preferably up to 5000 psi. The main features of good pumping, it can be capable at 5 into 10 to the power of 7 physical. It should be whole volume. So what are the injection port? The correct application sample Hplc column particularly important factor achieving the successfully separating to two injections methods. Exiting the first method uses the micro syringe and to inject the sample and either directly onto the column packing onto small plug inert material method immediately above the column packing. The second method sample injecting the retain the column the pressure by the sample loop injector. Metal loop has been fixed small volume that can be filled with sample. So by means appropriate switching system, the effluent from the pump is channeled through the loop. The outlet of the loop leads to directly onto the column. Therefore, sample is flushed onto the column by the effluent without the interruptions of flow to the column. So how this load position and injecting positions. So repeating applications of highly impure samples